All right, welcome to part 2 of graphing rational equations. We can also graph rational functions when it is not in the HK form, like we did in the previous video. If you notice, we just have a fraction over a fraction, and we know your q, which is on the denominator, can never equal 0. Now, we have something called discontinuities, and let's see, it's going to be a break in the graph. That's what a discontinuity is. There's going to be a break in the graph where the function is undefined. And it can be classified as removable or non-removable. Your non-removable discontinuity, it's going to occur when a factor cancels out and there's going to be a hole in the graph. Now, a non-removable discontinuity occurs when factors are in the denominator and there's going to be a vertical asymptote. So now what we can do is let's think about what it could look like for a removable discontinuity. So I'm going to start with my xy plane. And then I'm going to graph something. I'm going to graph an upside down quadratic, a parabola. It'll be negative x squared. So when something cancels, you're going to have an actual hole. So that part would not actually be there in my graph. There would actually be a break in it. So it's going to be here and then a big old hole right there. So literally a hole, just like when you have paper, you have it all printed out, it's all together when you get out of the printer. And then what we do is we put a hole in it to hole punch it. And those are actually removable discontinuities in our paper. So now what we have for non-removable is, if you think back to the last lesson, it was our asymptote. It's going to be the vertical asymptote. It's non-removable. So it's a break in my graph. Okay, so right here it's vertical. And it's not going to touch that. So that is non-removable and removable. So now what we can do is, let's take a look at these examples and say, what are the discontinuities that exist? Now, it actually has a couple of things here, okay? This right here is going to be my non-removable discontinuity because it's an asymptote. It's a vertical asymptote. And this right here is my removable because we have a hole. So we were lucky. We actually had two things going on. Pretty cool. Now, let's take a look at the next one. Do I have a little hole? We don't. We have just a non-removable discontinuity, the asymptote. And my equation would be x equals -4 for my asymptote. Now, this function right here actually has a special name. Later on, we're going to learn that that is a logarithmic function. You can say logarithmic function. Basically, it's just the inverse of an exponential function. It's okay. You'll see it later on, just so you see it now. Now, if you take a look at this right here, okay, if you notice, we have two pieces, all right? That is actually called a piecewise function because we are broken up into two different pieces. So if you ever have to see the words piecewise functions, because they are two functions put together. Now, whenever you see this, it has something called a jump discontinuity. Because it literally goes from here And then what does it do? It jumps up. That's a jump discontinuity. It's broken up into two different pieces. So we're going to have a little practice in order to figure out how to find out if there's a removable discontinuity. Now you have to factor the numerator and denominator to see if there is a whole. So let's see, it should be x plus 2, x minus 2 because they are difference of two squares. And on the bottom you say what numbers multiply to 6 but adds up to negative 5, x minus 3, x minus 2. And it should say if you can cancel a factor, then you will have a whole. Just because you can factor does not necessarily mean there's going to be a whole. So please make sure you make that change on your paper. Thank you. Alright, so we factored, and now we can cancel. If you notice, I can cancel this out and this out. Since you can cancel, we just found out that we have a removable discontinuity. So there is a whole. That's what happens. Alright, so there is a whole. Now, if you take a look at the examples above, if you notice right here, you can actually figure out what the coordinate point of your whole is. Has an x and a y. Now, here is how you're going to find the coordinate point for the whole. So what you're going to do is take a look at the factor that we canceled out. We canceled out x minus 2. So what we're going to do is you're going to do the opposite of the factor, so it's just 2. So this is going to be the opposite of the factor. So whenever your factor is a negative, the x value of your whole is going to be a positive, and vice versa. Now we know every x has a y, so what you're going to do is we're going to look at the part where you're after you cancel it out, we know we're left with this. Okay, so when we canceled, we know we simplified it and we know this is what it would be. So what you're going to do is take your x value of the whole, plug it in to whatever's left over, and then you just solve. 2 plus 2 is 4 over negative 1. So your y value of your whole is negative 1. So that is how you get your y value of the whole. So again, to find a removable discontinuity, you have to factor, you're going to cancel, find the opposite of your x value right here, and then plug it into whatever's left over. Done. So you literally would have a whole at 2, negative 1. It'd be like that in your graph. Now, let us talk about how we can find out our horizontal asymptotes. So now it says to determine the horizontal asymptotes, you're going to compare the degree of your numerator, which is on top, and the degree of your denominator, which is on the bottom. So remember that. N goes with the top degree and D goes with the bottom degree. Now, whenever your n is bigger than your denominator, when the degree of your top is bigger than the denominator, there is going to be none. So on my top, the degree of my top is 3, right? And then I can say the degree of my bottom is 1. So let us compare. 3 is bigger than 1, so that's why there is none. So again, n corresponds with the degree, the exponent on the top. So your top one is 3, your bottom one is 1, and 3 is bigger than 1, so that's why there is none. Now, what we're going to do for the next one is, when your n, your top degree, is equal to the bottom degree. Okay, let's see what happens. On this one right here, if you notice, my degree on top is 2. The degree of your bottom one is also 2. So since they are exactly the same, you're going to take a look at the coefficients in front and divide. So whenever, see how it's x squared? You're going to take a look in front. So your coefficient in front is a 4. And the coefficient in front of the bottom is a 1. So your horizontal asymptote is 4. Now let's take a look at the next one. When your n is less than the degree, okay, the denominator is y equals 0. So your degree of the top is 1. The degree of the bottom is 2. Since 1 is less than 2, your y is 0. Pretty much what you can say is, if it's bottom heavy, your y is equal to 0. So when the bottom is bigger, y equals 0. Now we can also find out what my x and y intercepts are by substituting 0 into your x or for your y. So now if you have an x-intercept, your y is 0. So what you can do is, the shortcut thing is, you can pretty much just take your top, your numerator right here, and set it equal to 0. And then you're going to solve for x. So we just found out what my x-intercept is. So that's your process for x-intercept. So you're going to let your y be 0 right here. And then you set the numerator equal to 0 and just solve. So my x-intercept is x equals -1. And of course, we know we need to write it as a corner point. So now if you want to find out your y-intercept, all you're going to do is plug in 0 for your x. So whenever you see an x, you're going to plug in 0, and then you'll solve. So this gives you 2. This gives you -3. So your y-intercept is 0, -2/3. Alrighty. So now what we're going to do is we're going to put all this together. Okay, are you guys ready? I think you are. It's okay. We're going to guide you through. Alright, step number 1 is, say, do I have to factor anything? I don't have to factor anything. So what we can do is find out what my ha and my va is. Now, your vertical asymptote is always x equals, and it is from the denominator. So your x is equal to -2. So that is your vertical asymptote. Okay? So now what we're going to do is figure out what my horizontal asymptote is. We're going to compare my degrees of my top and bottom. Now, if you notice, your degree of your x on top is a 1. Your degree on top is 1 as well. Now, what do you notice? They are the same. So you're going to divide your coefficients in front. So y equals 1/1. 1 divided by 1 is 1. So that is your horizontal asymptote. So we can have a dotted line going through -2 and also +1. Now, what we want to do is say to ourselves, can I cancel anything else out? We actually couldn't, so there is no hole. Now, we can also figure out what my domain is by saying x is not equal to -2, and then your range is y cannot equal +1. To find out your x-intercept, okay, what you're going to do is you're going to set your numerator equal to 0 and solve. So that is your x-intercept. It is 4, 0. Now to find out your y-intercept, what you're going to do is plug in 0 whenever you see an x. So then your y-intercept is going to be 0, comma, -2. Now, if you want to get those exact points, you're going to go to your calculator, you're going to go to your y equals, and you're going to type in alpha y equals, give you nice fractions, and then you're going to get x minus 4 over x plus 2. Hit second graph. And then you're going to plot those points. Now, if you look at it, -2 says error. That means that you found out the right vertical asymptote. So take all those points that you can see, and then you're going to plot them. So I have -1, -5. Okay, and I know my y-intercept. All right, so that's what one part looks like. And then we're going to do the same thing for the other one, the other side. So you can look at your graph. -3, 7. All right, and then you're going to kind of see what it looks like. There we go. Okay. Now, what we're going to do is we're going to do, for this one, I'm not going to graph it. We're going to kind of just go through the information so you can kind of see how it works out. If you need to see what the actual graph looks like, type it into your calculator and then get those exact points. Okay? So, now what we're going to do is we are going to have to factor first. You have to factor the denominator because it's the difference of two squares. And now you have to say, can I cancel anything out? Since you cannot cancel, there is no whole, there is none. Now, what we're going to do is find out what my vertical asymptote is, or are. We actually are going to have two of them. We're going to have one at -2 and one at +2. Since we know my x, my va, we also know my domain. X cannot equal -2 and +2. Those are the two things that it cannot equal. Now, my y equals. Take a look at the degrees. It's 2 and that's 2. So you're going to take the ratio of your leading coefficient. So it's 3 over 1. So your is going to be 3. So that means your y is not equal to 3. Now, to find out your x-intercept, we're going to set the top equal to 0 and then solve. Now, if you recognize it, my x-intercept is going to be 0, 0. And now what do you think your y-intercept is? It's also going to be 0 because if you plug in 0 on top, it's 0 over -4. And it's just going to be 0, 0. So now what I'm going to show you is what it's going to look like in the calculator. And then you can graph it on your own by looking at the table. And I believe that the int key that's on Vision also has what the points are and how it looks like. So we can actually just look at the graphs. Now, if you notice, it's in two parts. That's okay. It's still good. So when you're done with that, you got to make sure that you have your two dotted lines going through your x at -2 and +2. And x cannot equal 3 right here. Okay. Alrighty, let's take a look at this one. Very first thing is we have to factor first. X plus 2 times x minus 2 all over x plus 2. Now, what do you notice that I can do? I can cancel. So I can cancel, and I'm left with just x minus 2. So since I can cancel, that is going to be my whole. You take the opposite of what the factor is. And now to get your y value of your whole, you plug in -2, and you got -4. So that is your y value of your whole. So now what we have to do is look at whatever is left over, my x minus 2. And you have to say, is there a ha or is there a va? And I'm going to say that there is none. Because there is no denominator. And also, your degree on the top is bigger than the bottom. That's why there is none. So now what you can do is figure out what your x-intercept and your y-intercept is. So you're going to set 0 equal to x minus 2. And you get x equals positive 2. And that is your x-intercept. And your y-intercept is you're going to plug in 0 for x. And you get negative 2. So it's 0 comma negative 2. So now what we're going to do is we are going to plot my point at negative 2, negative 1, 2, 3, 4. And that's going to be a whole right there. And now what we're going to do is graph. Okay, I know it's a line. So 2. All right, and hopefully yours looks nearer than mine. There we go, close enough. So now it's in 2 parts. So now what we have to do is we're going to say our domain is, we're just going to use my x values of my whole. X cannot equal negative 2. And your y cannot equal your negative 4. So this time for your domain and range, we're going to get the values using your wholes. Number 4. Very first thing is you have to factor first. X plus 3, x plus 2, all over x plus 3, x minus 3. So I have a whole because I can cancel stuff out. And I know that my x value of my whole is the opposite. So it is going to be negative 3. To find the y value of my whole, I'm going to plug in negative 3 into whatever's left over after you cancel. And I get 1 over 6. And that is your y value of your whole. And now we actually are also going to have a vertical asymptote because in my leftover I have a denominator. Remember, denominator gives you a vertical asymptote. So it's going to be x is equal to positive 3. And my vertical asymptote is, so if I had to write it out, my vertical asymptote is x minus 3 equal to 0. And you get x equals 3. To get my ha, we know the degree on my top is 2. The degree of the bottom is 2. Since n is equal to d, you just take the ratio of the front, 1 divided by 1, so your y is equal to 1. To figure out your x-intercept, you're going to set your top equal to 0 and solve for x. So it's negative 2 comma 0. To get your y-intercept, all you're going to do is plug in 0 for x. All right, so you get 2 over negative 3. So now what we have to do is we're going to use a couple of different things for my domain. We have to use for my domain your value x cannot equal your vertical asymptote number and your x value of your whole. Now for your range, y can't equal the number in your horizontal asymptote as well as your y value of your whole. Now if you want to figure out what the graph looks like, you're going to go to your calculator and you're going to type in the whole thing, alpha y equals, press enter, and I get x squared plus 5x minus 6 press graph. Okay, if you notice, I have a couple of different parts, except we know that I have my vertical asymptotes. Hopefully I typed it in correctly. I don't believe I did. Let's see, what did I type in wrong? Let me retype it again. Alpha y equals, press under, x squared plus 5x, okay, plus 6. I did a minus 6, that's okay. Now I figured it out. X squared minus 9, press graph. There you go, that's better. So what I'm going to do is I'm going to plot my hole just so you can kind of see it. So my vertical asymptote and my horizontal asymptotes. So at -3, 1, 6. That right there would be my hole. So literally, it's a break in my graph. Okay, and we can get actually points. There you go. Okay, so if you notice, we got both removable and non-removable discontinuities. Alright, well, thank you for watching. Bye!